assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, this problem is asking some information about an electric shaver. We're given the information that as the blade oscillates, it travels a total distance of 2 millimeters. We are told that the frequency of oscillation is 120 hertz. And we're being asked to find what is our XM, what is our amplitude. We're being asked what is the max velocity. And finally, what is the acceleration? So for the first part, figuring out our amplitude, we just need to think about, okay, if it's oscillating, if it is oscillating between 2 millimeters, going back and forth between 2 millimeters, and that is our total displacement, then our amplitude is going to be smack dab in the distance between the middle to one of the ends. So we're just going to split that in half. So our XM is actually just going to be the 2 millimeters divided by 2, splitting it in half. So XM equals 1 millimeter. The next part, finding our max velocity, we're going to use the equation velocity equals omega times amplitude. However, we don't have omega in this situation. We don't have enough information to substitute in a number for that. So instead, we're going to swap out this term, omega, and we're going to use the equation omega equals 2 pi times your frequency. So our new equation for velocity is actually going to end up being 2 pi times frequency times amplitude, all of the information of which we now have, because we found our amplitude in part A and we were given our frequency in the actual problem itself. So when we plug in our terms, we have velocity equals 2 pi times 120 times 1. And when we solve for that, we get velocity equals 753 millimeters per second, which is an awkward term, so we should just go ahead and switch that into 0.75 meters per second. So that is our final, or our maximum velocity. The third and final part of this is figuring out the acceleration. So for acceleration, we're going to use the equation acceleration equals omega squared times amplitude. And again, we're going to swap out omega for our omega equals 2 pi f. So our acceleration equation is going to switch over to 2 pi f squared times our amplitude. Now acceleration is going to be put into meters per second rather than millimeters per second. So we are going to want to switch our amplitude from 1.0 millimeters to 0.001 meters in order to have an answer that is going to be in our standard unit for acceleration. So when we substitute in our terms, we have acceleration equals 2 pi times 120 squared times 0.001, and we get an acceleration rate of 5.7 times 10 to the second meters per second squared as our final acceleration value.